Hi everyone. So welcome back in this lecture series, and in this lecture number, I guess this is 13 or 14. Yeah. So in this, we will start from this question. That's theorem. Basically, we are given with two random variables, which are IID, which are independent, basically, from the normal mu comma sigma square. Then we need to prove that this y is equal to x1 plus x2 minus 2 mu will follow some distribution. See, I guess some of you people are thinking that this is something like standard normal divided by chi square. This will follow t distribution, but not exactly. This will not follow t distribution. Neither it will follow f distribution, neither it will follow chi square distribution. It will follow a distribution which is called a monkey distribution. बंदर जैसा एक डिस्ट्रीब्यूशन है वो, ठीक है ना? बंदर जैसा वो डिस्ट्रीब्यूशन है, उसका कुछ भी एग्जिस्ट नहीं करता है, ठीक है? बस ऐसी लटका रहता है हवा में. दैट इज द डिस्ट्रीब्यूशन विच इज कॉल्ड डाइजेस्ट डिस्ट्रीब्यूशन. वो मैं बताऊंगा, वो हम प्रूव करेंगे. लेट्स गिव अ ट्राई ऑन दिस क्वेश्चन. एंड दिस क्वेश्चन, ये जो क्वेश्चन है, ये कभी पूछा नहीं गया है कभी भी एग्जाम में. आई गेस जैम में नहीं पूछा है, गेट में नहीं पूछा है, सीयूटी की तो बात ही नहीं है. वो इतना टफ क्वेश्चन कहाँ से पूछेगा? तो लेट्स गिव अ ट्राई, देखते हैं क्या होगा, ये कौन सा डिस्ट्रीब्यूशन होगा, ये कौन सा डिस्ट्रीब्यूशन होगा ये. ठीक है, एज यू नो, x1 किसको फॉलो कर रहा है? नॉर्मल म्यू कामा सिग्मा स्क्वायर, और x2 नॉर्मल म्यू कामा सिग्मा स्क्वायर. तो x1 प्लस x2 किसको फॉलो करेगा? 2 म्यू 2 सिग्मा स्क्वायर. क्लियर? तो इसको अगर हम स्टैंडर्ड नॉर्मल में कन्वर्ट करेंगे, दिस इज x1 प्लस x2 माइनस 2 म्यू divided by under root 2 sigma square, and this will follow normal 0 comma 1. This will follow normal 0 comma 1. Clear? and अगर हम यहां से निकालेंगे x1 minus x2, तो this will follow normal 0 comma 2 sigma square, and x1 minus x2 divided by 2 under root 2 sigma, this will follow normal 0 comma 1. and see if I take x1 plus x2 minus 2 mu divided by 2 sigma under root 2 sigma square का whole square, और इसका भी x1 minus x2 divided by under root 2 sigma का whole square, this will follow chi square 1, this will follow chi square 1. Clear? So as you know from the sampling distribution, x1 and x2 are independent. So x1 plus x2 and x1 minus x2 will also be independent. Is it correct? So which implies that covariance between x1 plus x2 comma x1 minus x2 will be 0. Right? Also let's write this as uh, this is phi 2 and this is phi 1. This is phi 1. So this will follow this and this will follow this. Clear? So say phi 1 and chi square are independent random variables, and phi 2 and chi square are independent random variates or random variables. Random variates, yeah. Then by t statistic by t statistic, t is equal to phi upon chi square with 1 degree of freedom will follow t1. As you know this, as you know this, then then this will follow t1. Clear? And see, if I write t is equal to x1 plus x2 minus 2 mu divided by sigma root 2 whole divided by, or I can write this as like this, under root of x1 minus x2 whole square with degrees of freedom, or with like this, or we can say sigma root 2. What I did, see, this is my chi square 1. This is my chi square 1, and this is standard normal variate. So see, t is equal to x1 plus x2 minus 2 mu divided by, can I write this as this and this will cancel out. So can I write this as you know, mod of x is equal to x square. Mod of x minus y is equal to x minus y whole square. We can write this. You can prove, can Google it, how this is equal to this. I'm not going to show you how this is equal to this. So x1 plus x2 minus 2 mu divided by under root, can I write this as x1 minus x2 whole square follow t1. Clear? Now, what will be the PDF of this t distribution? What is the PDF of t distribution? As you know, f of t is equal to 1 upon, this is equal to beta 1 by 2 comma n by 2 1 upon 1 plus t square upon n plus 1 by 2. Now put n is equal to 1. Put n is equal to 1 as we have the t1. So this distribution will reduce to 1 upon beta 1 by 2 comma 1 by 2 1 by 1 plus t square. Why this is from minus infinity to infinity. From minus infinity to infinity. So see, if I write this is 1 upon gamma 1 by 2 gamma 1 by 2 gamma 1 by 2 plus 1 by 2 1 upon 1 plus t square. So this is becomes 1. This is 1 divided by, this is 1 divided by under root pi 1 by 1 plus t square from this to this. So this becomes 1 by pi 1 upon 1 plus t square minus infinity to this. So This is the PDF of Cauchy 0, 1. So now, yeah, so the distribution of y is equal to Cauchy 0, 1, which is equivalent to T1, which is equivalent to T1. So the distribution of y will follow Cauchy 0, 1, which is equivalent to T1. Simply, which is equal to T1. Clear? Clear? Yes. Now, let's see another question or another theorem. Theorem is, let x1, x2 up to xn be a random sample from normal mu comma sigma square, and x bar and s square be the sample mean and sample variance, then let xn plus 1 will follow normal mu comma sigma square, and assume that x1, x2 up to xn plus 1 are independent. Then obtain the distribution of, then we need a distribution of what? Distribution of u is equal to xn plus 1 minus x bar divided by s into under root n plus 1. So see, what is the question? The question is simply, it's asking that you need to find the distribution of this if x1, x2 up to xn be a random sample, that is from normal distribution. Whenever you see random sample, this means that xi, x1, x2 up to xn, that's xi's are independent, right? So we need to find the distribution of this. This is simply t distribution. See, this is s. This will follow the chi-square. S square will follow the chi-square. See how? And this is my normal. So directly you can say this will follow t. But here is the work of degrees of freedom. What will be the degrees of freedom? So see, let's give a try on this. This is nothing but, see, this is nothing but how we can solve this. So solution is my, as you know, from this, what's x bar? That's 1 upon n summation xi. I is equal to 1 to n. What is my s square? That's 1 upon n minus 1 xi minus x bar whole square. I is equal to 1. See how this is chi-square. See, sigma square summation xi minus x bar whole square sigma square. So this will follow chi-square. This will follow chi-square n minus 1. This will follow chi-square n minus 1. So if I take the expectation of s square, that will be sigma square n minus 1 upon n minus 1. This and this goes. This is unbiased estimator of this. So this is chi-square. Simply you can say this is chi-square. So see now, chi-square is summation xi minus x bar square. divided by sigma square. So this is chi square. Clear? Can I write this as n minus 1 s square upon sigma square? And this will follow chi square n minus 1. Clear? And also x bar and s square are independent. Already proved. Clear? So what will be the distribution of xn plus 1? So this is normal mu comma sigma square. What will be the distribution of x bar? This will follow normal mu comma sigma square upon n. So what will be the distribution of xn plus 1 minus x bar? So this will follow mu minus mu, that is 0, and this variance term will get added. So this will become sigma square plus sigma square upon n, and the covariance will be 0 as they are independent. So this will follow normal 0 n plus 1 divided by n into sigma square. Clear? Now t is equal to xn plus 1 minus x bar divided by this n plus 1 n sigma square with under root. This will follow normal 0 comma 1. Let's give this and the name as phi. The phi is my this will follow normal 0 comma 1. Clear? And what's s square? That's 1 upon n minus 1, or simply n minus 1 s square. Sigma square will follow chi square n minus 1. So see, remember. So see, the t will be phi upon under root chi square with n minus 1 degrees of freedom. So this is nothing but n plus 1 x n plus 1 minus x bar divided by sigma. So this is nothing but we have chi square in denominator. Here we have chi square in denominator. So see, this is my phi divided by under root n minus 1 s square sigma square into 1 upon n minus 1. So this will follow t n minus 1. This will follow t n minus 1. So u is equal to xn plus 1 minus x bar divided by s into under root n plus 1 will follow t n minus 1 degrees of freedom. Clear? T n minus 1 degrees of freedom. Hence proved. And from previous lecture, add this to the previous lecture. From previous lecture, that I told you about the graph of the t distribution, that's t is equal to 0. Remember, probability mod of t is greater than t naught will always greater or equal to probability z greater than z naught. Mod of z greater than z naught. So the value probability, this is minus 2, this is 2. Probability t greater than t naught, that t naught is observed value. This is my observed value. This is my observed value. This is observed value. This is observed value. So probability t, the value of t greater than some observed value, will always greater than this. If you have degrees of freedom, that x follows t with n degrees of freedom, and y follows t with n plus 1 degrees of freedom. So this will be nothing but probability x greater than t greater than probability y greater than t. One thing is this, then another thing is this. Both are valid. Both are valid. Let's take the mod of this. Yes, t will be some observed value. This will be observed value at different degrees of freedom. As you can see, whenever degrees of freedom increases, or when degrees of freedom tends to infinity, the t distribution tends to normal distribution, right? So area will be, the area under the curve of this will be more than this. Clear? So this is my graph. Clear? This is my graph. So now, most important question is, if x bar and s square be the usual sample mean and sample variance based on random sample of n observations from normal mu comma sigma square, and if t is equal to x bar minus mu upon s divided by under root n, which is test statistic, then prove covariance between x bar and t is equal to sigma under root n minus 1. This is gamma n minus 1, sorry, this is gamma n minus 1 gamma n minus 2 upon 2 divided by gamma n minus 1 divided by 2. This is gamma or under root. Wait a minute. Then prove covariance between x bar and s square. That will be equal to sigma under root n minus 1 upon 2n, yeah, gamma n minus 2 divided by 2, gamma n minus 1 divided by 2. We need to prove this. If x bar and s square be the usual sample mean and sample variance based on the random sample of n observations from this and this, then prove this is equal to this. This is equal to this. This is equal to this. So see how we can write the covariance between two random variables. That is simply expectation of x, y minus expectation of x, expectation of y. So we have covariance between x bar comma s square. That will be nothing but expectation of x bar s square minus expectation of x bar expectation of s square. So if I talk about the t distribution, that's the t simply. So expectation of t is equal to 0. Expectation of t bar will also be equal to 0. This means that expectation of x bar will also equal to 0. So this term will be 0. As this is 0, so this whole term will be 0, but not in this case. Now, oh, I'm sorry. This is not s square here. This is t. that we have already defined the t here. This covariance between x bar and t. T is test statistic. This is another theorem. Covariance between x and s square is another theorem. We will then prove that also in next lecture or in f distribution. So see, this is x bar comma t. Yes, this is again same. Yeah. So this will be 0. So now see, if I write this expectation of x bar minus mu plus mu into t, it doesn't affect our this becomes minus plus, again this will be cancelled out, so we will get expectation of x bar comma t as it is. As expectation of t is equal to 0, can I write this as expectation of x bar minus mu t? Once you solve this, you will get back this. Clear? See how this is equal to this. So multiply x bar t, this is equal to this, then expectation of t mu. Expectation of t is 0 and mu is constant. So see, expectation of mu t is equal to mu expectation of t. So mu is constant, expectation of t is 0, that is becomes 0. So expectation of x bar t minus expectation of mu t is equal to expectation of x bar t as it is, right? As it is. Now what we will do from here, क्या करेंगे हम यहाँ पे? See, this is equal to expectation of x bar minus mu. What is this t? What is this t? This is x bar minus mu upon s divided by under root n. Clear? So this is nothing under root n expectation of 1 upon s into expectation of x bar minus mu square. Clear? See, this is expectation of 1 by s, and this becomes expectation of x minus mu whole square. Clear? So this is this, and what is this? Expectation of x minus mu whole square is variance of x. So here is x bar, expectation of x, this is x bar, yeah, variance of x bar. This is x bar minus mu whole square is equal to variance of x bar. So this is nothing but expectation of x bar square minus expectation of x bar whole square, which is variance of x bar. Clear? So this is under root n expectation of 1 upon s into variance of x bar, variance of x bar, variance of x bar. So this is nothing but under root n, what's expectation of 1 by s into variance of x bar? That is nothing but sigma square upon n, sigma square upon n, that's variance of x bar, as you know from the sampling distribution, that's sigma square upon n. What's expectation of 1 by s square? That is nothing but 2 sigma square upon n minus 1 raised power minus 1 by 2 gamma n minus 1 divided by 2 minus 1 by 2 divided by gamma n minus 1 divided by 2. You can also prove expectation of 1 by s for t distribution. That is nothing but this. This is expectation of 1 by s square is not for t distribution, it is basically for chi-square distribution. Expectation of 1 by s for chi-square distribution is this, for chi-square distribution. expectation of 1 by s is equal to this. So this is nothing but 1 by under root n. Once you solve this, see this n and this n. Can I write this as under root n under root n under root n n? So this is nothing but n divided by n under root n. N cancel. This is 1 upon under root n. So from this I can write this, and which is n minus 1 upon under root 2 into sigma, then gamma n minus 2 upon 2 divided by gamma n minus 1 divided by 2, which is equal to sigma n minus 1 upon 2n gamma n minus 2 divided by 2 gamma n minus 1 divided by 2. Hence proved. Hence proved. If you are asked to find the correlation coefficient, that's R, between x bar comma t, that will be nothing covariance between x bar comma t, variance of x bar, variance of t का whole root. This is nothing sigma n minus 1 upon 2n gamma n minus 2 upon 2 divided by gamma n minus 1 divided by 2 whole divided. What's variance of x bar? That is sigma square upon n. What's variance of t? That's n minus 1 upon n minus 3, n minus 2, n minus 2. If variance of t is equal to this, that is n minus 2, which is equal to 1 minus n by 2. Is this clear? No. This n minus 2. So you can use variance of t as n minus 2. Also you can use this is n minus 1 upon n minus 3. This is n minus 3 as this is n minus 3, not 2. This is n minus 3. Both are same. Variance of t is this and this. Both are same. Both are same. Both are same. So see, this is nothing but under root n minus 3 divided by 2 gamma n minus 2 divided by 2 upon gamma n minus 1 divided by 2. This is the answer. This is the answer. So on the basis of this concept that variance of t is this, IIT Kharagpur has asked, I guess, उन्होंने पूछा है, ये मैं बता देता हूं कि क्वेश्चन क्या है. The question is from IIT Kharagpur. The question is, I guess, let me check. The question from IIT Kharagpur कि क्या पूछा था उन्होंने. से क्वेश्चन क्या था? IIT खड़गपुर का ये क्वेश्चन है. क्वेश्चन क्या था भाई यार? देखो क्वेश्चन क्या था. क्वेश्चन वाज लेट x1 x2 up to xn follows IID normal mu comma sigma square, and x bar is equal to 1 upon n summation xi, s square is equal to 1 upon n minus 1, that sample variance summation xi minus x bar whole square. Then false statement. पहला, under root n x bar minus mu upon sigma will follow normal 0, 1. Under root n x bar minus mu upon s will follow t n minus 1. Number 3, variance of under root n x bar minus mu upon s will converge to 2 as n tending to infinity. Fourth, the PDF of under root n x bar minus mu upon s converges to PDF of standard normal variate as n tending to infinity. So this was the question that IIT Kharagpur has asked. To say, we need to find the false statement. So as you know, this is true as sigma is known. Sigma is known. That's why we write sigma. And here sigma is unknown. When sigma is unknown, we replace this sigma by s or sigma by s, sigma square by s square. So this is follow. This is Tn minus 1. This is true. This is true. Both are true. And see, this is true. This is true. Then the PDF of and in last lecture we saw the graph of t distribution as for n degrees of freedom or n tending to large. The PDF of t distribution will tend to the standard, will reduce to the standard normal distribution. This is also true. Clear? But comment on this. See how here they are using that variance of this t is equal to n minus 1 upon n minus 3. Right? Say limit n tending to infinity, variance of t is equal to, make n common, n 1 minus 1 upon n, n 1 minus 3 upon n, 1 minus 3 upon n. So this and this will get cancelled out. So when limit n tending to infinity, so 3 by infinity tending to 0, 1 by n tending to 0, so this will become 1. So this is my false statement. If I use here n minus 2, make n common, 1 minus 2 upon n. Say this n goes, 2 by n tending to 0, so this is 1. This again converging at 1. This was the question that IIT Kharagpur has asked. So this was the last lecture of your t distribution. This was the last lecture of t distribution. And in next lecture we will see f distribution. Hopefully we will see f distribution. Right? We will see f distribution. So thank you, and do like and comment on this video lecture and subscribe to my channel. Take care. Bye.